Hello guys, welcome to part 2 with proportions. Now that we have learned how to write and how to identify proportions, now we are going to use that knowledge to go ahead and solve for proportions. Vocabulary for today will be cross product. We already saw cross product in the last lesson, so let's do a very quick recap. And here we have for two ratios the product of the first term in one ratio and the product of the second term in the other ratio will form a cross product. Okay, so what do we mean by this? We saw on the last lesson, if I were to do 6 times 5 or 2 times 15, they should be equal to one another. So here we see 2 times 15 is 30 and 5 times 6 we get 30. So yes, those two ratios will have a proportional relationship. Alright, so here it is in algebraic terms. In the proportion A to B is equivalent to C to D, where B and D cannot be 0. Now, why do we identify that B and D cannot be 0? Because in reality we cannot divide by 0, otherwise our answer will be undefined. So we need to make sure we specify here that B and D cannot be 0. So if I were to multiply A times D, AD, and multiply C times B, my answer should be equal, similar to the previous slide with the numbers. Alright, so here is a proportion, but now, oh my god, we're missing a value. So we need to figure out now what number can we plug in here for M to make this equation true. So there's two ways we can do this. We can actually go ahead and treat them like fractions. So let's do it over here. 9 to 15. We can ask ourselves, how did we go from 15 to 5? Of course, we divided it by 3. So if I divide the denominator by 3, I can also do the same to the numerator. And 9 divided by 3, that will be 3. So the value that I need to plug in here will be 3. And if we test it out with the cross product, 3 times 15 we get 45. And 9 times 5 is 45. So yes, this check out, the 3 check out. Now a different way that we can solve this, let's change colors. Alright, so a different way that we could solve this is to actually use the cross product themselves. So if I were to do, because I know when I do 9 times 5 I will get 45, and 15 times M, so I can use that knowledge. 9 times 5 I get 45, and then 15 times M, they should be equal to one another. So now I set up an equation and solve for M, and I divide by 15. So 15 cancel, and 45 divided by 15 is 3. And if I plug 3 in here again, same answer, I will get 45 and 45. So two ways we can do it, by actually using the cross product, or by see how we could reduce this. What value are we missing since this one right here was reduced? Alright, so let's go ahead and do some examples. Alright guys, go ahead and find the missing value for M and the missing value for R here on the second proportion. Alright. Okay, welcome back. I hope you guys actually paused and tried them. So let's go ahead and find what's the missing value here. Now looking at this, 7 times 2 will give me 14. So if I do 6 times 2, I should get 12 as well. Or if I do 6 times 14, I'll get 84, and then divide 84 by 7, that will give me 12 as well. Now this one here, 6 and 7 do not like each other, so I have no choice but to go ahead and use the cross products. So 9 times 7 we get 63, and then 63 divided by 6 again, that will give me 10.5. okay. Alright, now this is very important. Now it is extremely important that we when we set up the proportions, we set them up correctly. So here is a problem. We have suppose a boat travels 16 miles in 4 hours and 8 miles in X hours at the same speed. Either of these proportions could represent this situation. So I can actually do 60 miles per hour again. So this will be comparing the first to the second. So we have the first boat. So that will be, again, if you notice, this is the boat, first boat, second boat. Hours for the time for the first boat, time for the second boat. And over here we can actually compare the miles. So 16 miles, again, this will be for the first, and then the 8 for the second one. Now we have to be careful here. When I'm going to put the 4 hours, I have to make sure I keep it with the first one, because the 4 hours belong to the first one and we do not know which one belong to the second one. Alright, so let's go ahead and solve this problem together. Alright, so here we have, if 3 binders of the same size take up 4 inches of space on a shelf, how much space will be needed for all 26 of these binders? So here we have we can actually set up a proportion. So we can actually do binders to size, right? So binders to space. That is the first thing I will advise you guys to do, is to write down the comparison, how you guys want to compare them. I decide to do binders to space. So that means for 3 binders, how much space did 3 binders take up? 4 inches. Okay, now I have 26 binders. Now where will I put my 26? Top or at the bottom? Now 26 binders has to go with binders, so I need to put it on top. And now I need to find the space that I do not know. Okay, and then here we can go ahead and find their cross product. Let me bring up the cal here. So now we can do 26 times 4 and then divide it by 3. And that will be about 36.6. Okay, the 6 keep repeating, so we could actually round it off to maybe about 36.7. But okay, so here we use the knowledge of proportion to figure out how much space will 26 binders take up, knowing the ratio is 3 to 4. For every 3 binders take up 4 inches. Again, most important thing here is how we set up a proportion. For example, I cannot say I'm gonna do binders to space and then I put 3 binders is equal to 4 inches, and then when I get here I flip it. I put my X here for the space and my 26 here for binder. If you look, 26 binder and binders is on top. No. Alright, here's a problem. Go ahead and solve it by yourself. Remember to set up the proportions correctly, keeping them constant. Alright, let's go. Alright, welcome back. So let's read the problem. A stack of 33 CDs is 1.5 inches high. How many CDs will be in a stack of 3.5 inches high? So again, here let's go ahead and set up a proportion. First thing I want to do is write down what am I comparing. I'm comparing CDs to height. Okay, to how tall they are. Number of CDs to the height of the stack. Alright, so here I have 33 CDs was 1.5 inches. Again, CDs, height of CDs of the stack, height. Alright, and then they want to know how many CDs will be in a stack of 3.5. Now, where will I put 3.5 inches high? That's my height right there. That's the stack. 3.5 will go here, and of course the number of CD that I do not know will be my variable, will be my X. And then here again, let's go ahead and bring up the cal again so we can go ahead and solve the proportion. Alright, so here we will do we will do 33 times 3.5 and then divided by 1.5. Okay, so and just to refresh on 77 CDs. Okay, to make up a stack of 3.5 inches tall. Okay, let's do one more example. Alright, here's one more. Go ahead and do it by yourself and then come back and get the answer. Alright, welcome back. Well, this one I'm not going to work it out. I'll go ahead and use the one on the slides. So here we have Maria drives at a custom speed for 3 hours and travels 175 miles. How far will she drive in 4.5 hours? So here they set up the proportion here. They put time to speed. Okay, so and then here we have the time. Time needs to be on top since time alright, so this is time to speed. Alright, so this also has to remain constant. Time to speed. Now we could flip them around. It wouldn't matter. So we could do speed to time, as long as we make sure we write everything the same. We also flip everything else. So again, just to show you that there's different ways that we could write the ratios, the proportions, as long as they are constant. Alright, so that'll be, here's my answer right here, will be 262.5 miles. Alright, well, that's it for today. Again, we will have a quiz in class for XPs. Any questions, guys, please post them on Edmodo so we can discuss them as we go along. And that was it for today. You have a good one. Bye bye.